Hello, ladies and gentlemen. My name is Meshak Ndlovu. Name of the course is Probability and Statistics. The code is ESG 1111. So that's the code of the course. So the outline. So we're going to look at introduction, probability theory. We're going to look at random variables, distributions, moments, and some statistics. And then from there, chapter 4, we'll look at exploratory analysis and introduction to inferential statistics. Chapter 5, we're going to look at more on inferential statistics, things like goodness of fit, contingents, and tables, and the analysis of variance. Chapter 7, we're going to look at regression. Chapter 8 will cover stochastic and random processes and time series. Chapter 9, that's spatial point patterns, and the geostatistics and Kriging method will come in chapter 9. So what is statistics? So statistics is a field of mathematics that deals with collection of data, presentation of data, analysis of data to make decisions in terms of solving problems, designing products, and some other processes. In simpler terms, statistics is the science of data because many aspects of engineering practice involves working with data. And obviously, knowledge of statistics is just as important to engineers as are to engineering science. So we have a variable. So a variable is a symbol, a name associated with a value x. So you recall an equation of a line y is equal to x plus 4, say. So x and y are variables because they are symbols which are used to assign values on this equation. Right, so simple classification of variables. So we have got a continuous variable. So a continuous variable is the one that takes real numbers. So it takes elements from real numbers, and then a discrete variable is one that takes integers. These are counting numbers. So these are discrete, and then there is a process of moving from continuous to discrete. So we can move from continuous to discrete. So continuous variable, examples of continuous variable, suppose we have got a mass of 3 students, so 0.51, 0.75, and then we have got 0.01. So we can convert this to discrete. Suppose we say that we classify this can classify this and then say if anything falls in between 0 to 0.5, we represent it by 1. If it falls between 0.5 to 1, we represent it by 2. So in this case we have In this case, we have 0.151 represented by 2, and then 0.75 represented by 2, and 0.01 represented by 1. So the process of converting continuous variables to discrete variables, we call it discretization. So on that note, homework, go and look at fuzzy numbers. So the other method for discretization is by using fuzzy numbers. So as homework, go and look into that, how you can convert continuous numbers into fuzzy numbers. And this also has to do with classification. So that's it. And then the discrete variables are subdivided into two. We have got the categorical ones, and then you have got the numeric. So the numeric ones, these are numbers, and then on the categories, we have categorical variables, we have got categories, e.g. we can have a variable capturing sex. We have got F for females and males. So this variable is capturing variables sex, and then as male or female, we can have a variable which captures grades A, B, C, D, E, grades. So a variable that categorical variables are then subdivided into two. So the ones that are categorical but with no order, which do not follow any specific order, we call them nominal, example sex or gender. And then there are those which follow some order, we call them, for example, grades, marks, we call them ordinal categorical variables. So an independent variable is a variable that does not depend on any variable. For in this case, x is an independent variable, and then in this equation, y is dependent on values of x. You remember that a function given by a to b is a set. A function is also called a mapping, a map, or a mapping from a set A to set B. So a mapping from a set is a mapping is from a set A to set B is called a function. That's a function. So a function. So in this case, usually this B represent our y, which is our dependent variables, because functions say of f of x is equals to x squared. The function, this one sometimes denoted as that, this function is simply telling you that it is dependent on x values, and these x values are independent values. And then types of statistics, we have got different types of statistics. We have got descriptive statistics. So descriptive statistics encompasses things like graphs, tables. These are things that we can see. And then exploratory data analysis refers to descriptive statistics using a collection of visual and numerical tools such as quartile, box plots, and auto correlation. And then inferential statistics is statistics that deals with comparing data sets. So suppose you have got a population, and then from a population you then pick up a sample. Then this is this population. So if you have got a population, and then from that population you pick up a sample, and then whatever the results that you get from the sample, you can then infer them back to the whole population. So that's what we call inferential statistics. And then regression deals with building models. These models can be used to predict variables. For example, if we have mx plus c, the equation of a line, I can use this line to determine the y value at x is equals to say 4. So that's predictive statistics. You use the equation to predict if you have the model of those. So that's a regression. So we are fitting in a regression, we are fitting data into models. So that's what we will cover in regression, fitting data into models. Time series, I think I'll skip this part. Alright, so calculations and graphs. Alright, so we have got two things, a statistic is a measure. So a statistic is a measure of the sample. So if we take any measurements from the sample, we call them statistic. For example, the mean of the sample is represented by x bar, whereas the mean of the population, and we call this population parameter, is represented by mu. This is the mean of the population. So whatever measures we take or made from the population, we call them population parameters. So these are measures from the population. So a sample mean is given by x bar, which is equal to 1 over n summation of xi from I is equals to 1 to n. And then we look at sample variancy. A sample variancy is given by s squared plus the symbol, which is equals to that formula there. Make sure you memorize these formulas. Don't cram, make sure you memorize. And there is a relationship between sample variancy and the standard deviation. The standard deviation is the square root. Standard deviation is the square root of the variance. Alright, so we have got the stem and leaf, and then we have got histogram. Make sure you practice how to draw these graphs, use this data, and try to draw a histogram. So a histogram is a graph that looks like this. So homework, use 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 Excel to to draw a histogram of this data. So use this data and then you draw a histogram, and this will constitute your project that you will submit at the end of the course. So for the project number 1, use Excel with this data and then compute a histogram. Alright, so thank you very much. We'll end it there for this lecture.